In this section of Astronomy State of the Art, we'll consider stars. The story of stars is our story, too, and the story of life. Every one of the carbon, nitrogen, and oxygen atoms in our bodies was once part of a star, was created in the core of a star before the solar system formed and far off in space. The explanation of the periodic table and the cosmic abundance of elements is one of the great stories of astrophysics that's been told in the last century. The Sun is an archetypal star, but it's not a typical star. Telescopes in space like the Spitzer Space Telescope and infrared techniques from the ground have given us insights into star formation, which happens in the dense, murky regions where clouds of dust coagulate and collapse to form a young star and its surrounding planets. There are many stars that are converting hydrogen into helium, as the Sun is doing, but are much less massive and so will live longer lives. A relatively small number of stars are more massive than the Sun and live shorter, more dynamic lives, ending violently. The story of stellar evolution is a story driven by the mass of the star, which dictates everything from the speed of its evolution as a main sequence star, converting hydrogen to helium, to the nature of its death. Low-mass stars dying as white dwarfs, as the Sun will do, after a violent phase of red giant and planetary nebula, and high-mass stars dying explosively as supernova, leaving behind exotic remnants of neutron stars or black holes. We'll look at the way stars evolve, how they create their heavy elements deep in their cores at enormous temperatures, exceeding billions of Kelvin for the most massive stars, and we'll look at the endpoints of their evolution, at the exotic and collapsed states of stars where matter is far beyond terrestrial normal matter densities. The most exotic of these endpoints are neutron stars and black holes. A neutron star is like an enormous atomic nucleus with an atomic number of 10 to the 57, and a black hole is perhaps the most enigmatic object in astrophysics. Who knows what lurks beyond the event horizon? We cannot tell. It is an information membrane sealing off what happens within. But astrophysicists have learned to show the existence of black holes by their interaction with neighboring stars in a binary system, so we are very confident that they exist. Black holes are also the ultimate testing ground for our theory of gravity, general relativity.